So question D, how does the basicity of phenylamine compare to that of ethylamine? Explain your answer. Okay, so you have to know that their basicity depends on the lone pair on the nitrogens. So whether they are available to attract the protons or not available to attract the protons. So for phenylamines, so you have to imagine that the nitrogen, which has lone pair, and that lone pair is delocalized to the benzene ring. So it is not available to attract protons. So because of that, it is weak. And ethylamine, imagine that the nitrogen with lone pair. So that lone pair is available, and some more the ethyl here, which is the C2H5, will donate electrons to the nitrogens, making the lone pair more negative. So it is a very good in terms of basicity. Okay, it is a good base. Okay, now let's see how we write the answer. So we have to say that phenylamine is less basic than ethylamine. So comparison, 1 mark. Now we explain it in short. So we just said the lone pair on nitrogen is delocalized over the ring. Okay, so now let's see the next one. Phenol can be synthesized from phenylamines in 2 steps. Okay, so phenylamines, step 1, so you have to change it to something, and then step 2, you get phenol plus nitrogen, N2. So when you see this N2, right, so I hope you remember something that we learned before, N2. So these nitrogens, you can see that when it is in phenylamine, it is just 1 nitrogen. So to form 2 nitrogens, so they need to form Diazonium salt. So that is the first step. Okay, so I fill in the space over there first for structures E. So they have to form this structure, the diazonium chloride. So this thing. Okay. To form this, we have to write down the reagent and conditions for step 1. So which is nitrous acid. Or you can also write sodium nitrite plus HCl. This one will do also. Then we write the condition. Temperature less than or equal to 10 degrees Celsius. Okay, so you have to remember this condition, of course. And a very quick revision. So if you are wondering what kind of reaction is that again, so I put it at a short note here. Okay, so phenylamine react with nitrous acid. So nitrous acid is actually something like this. Together with HCl. Okay, so they will form benzene diazonium chloride. Okay, and then 2H2O. Okay, so if you still remember, the explanation is something like this. So this is the H2O, the first H2O. This is where they get the second H2O. And then after taking out the H2O, then you can see that this nitrogen form triple bond with these nitrogens. So that's why there's a triple bond here. So this is the benzene diazonium chloride. So this N triple bond N is called azole. It's called azole. So then chloride is because of the Cl minus. Cl minus come from here. So this is the situation. So remember the temperature. In the notes we put 5 degrees Celsius, but here it is more flexible. You can put any temperature less than or equal to 10 degrees Celsius. Okay, then step 2, how to change it to phenol. So basically we have to take it in this way. We have to keep our benzene diazonium at low temperature. If let's say the temperature is not that low, they will straight away become phenol and nitrogen gas. So step 2 is quite easy. You don't maintain the 5 degrees Celsius, then they will change to phenol and nitrogen gas. So what we can do here is we can boil or heat in water. Then the benzene diazonium chloride will become phenol. Okay, so let's go through a little bit more. This side. 2-bromopropane can be used to synthesize methyl ethylamines and 2-methyl propylamines. Okay, so which is the product? Okay, the product. So this is the one, but methyl ethylamines. Okay, so the structure is like that, and then 2-methyl propylamines. So it look like that. Okay, then draw the structures of the intermediate X in the box above. Okay, draw the structures. So we have to think about how to change 2-bromopropane to X and then to 2-methylpropylamines. What is obvious here is you see the number of carbon. So we have 1, 2, 3, 4 carbon. But the reactant here, the starting material here, we have 1, 2, 3 carbon only. So in order to increase the number of carbon, so you have to think of the AS chemistry, our bromoalkane. You want to increase carbon, you have to make it react with cyanide. Okay, that will increase. The number of carbon. Okay, react with cyanide. So what kind of cyanide? So it is actually potassium cyanide, for example. I put it in reaction 2 first. Potassium cyanide, KCN, and reflux in ethanol. So we need ethanol to dissolve the bromopropane. So that's why we need ethanol. Okay, so KCN also, KCN, what happened is the CN, right? The CN will go and as nucleophile to replace the bromine. Bromine will come out at the end. So because of that, we can easily think of the product. So it will be like this, the product. C triple bond N. Okay, it's the same structures. The only thing is the Br become C triple bond N. And after that, reaction 3 is where you have to change it to NH2 over here, and this carbon is CH2. So you have to change this C to CH2, you have to change this N to NH2. So we should expect some reduction here. So we can use lithium, or maybe hydrogen plus nickel. This is one option. Or if you don't want this option, you can put lithium aluminum hydride It's a reduction process. And then reaction 1. So let's see reaction 1. Reaction 1, which is here. Obviously, what happened is there is no change in the number of carbon. Okay, so you want to change bromine to NH2. Again, this is AS chemistry. We can just use ammonia in ethanol. So ammonia in ethanol under pressure and heat. Okay, so now B1, write an equation showing why aqueous solutions of ethylamine are alkaline. Okay, to write the equation, so you have to show that it is a proton acceptor. Okay, so ethylamine is ethylamine. Okay, it's none of the structures here, so we just put it as CH3, CH2. This is ethyl, and then amine and H2 react with H2O. They dissolve in water, and then the nitrogen act as proton acceptor, so it accepts protons from H2O, CH3, CH2, and H3 positive. So it take the proton now. The water which loses proton and become hydroxide ions. So from here, we can see the production of hydroxide ion make the solution alkaline. So part 2, compare the basicity of ethylamines and ammonia. So ethylamine, of course, is a stronger base because the ethyl is electrons donator. Okay, it donate electrons, make the nitrogen more negative, and the lone pair of nitrogen is more negative. So it is a better proton acceptor. Okay, so we put it in this way. Ethyl amine is more basic than ammonia. And then we write the reason, because of electron donating group in ethylamine. Okay, the third optional point, which make the lone pair on nitrogen more available for H plus. Okay, so this is how we explain it. And then, okay, let's move on. Okay, let's see C. Solutions contain mixtures of amines and their salts are buffer solutions. Explain what is meant by the term buffer solutions. Okay, so you must remember buffer solution is a solution that resists the change in pH. Okay, so solutions which resist changes in pH when small amount of H plus or OH minus are added. So this is the definitions of buffer solutions. So write two equations to show how a solution containing a mixtures of CH3NH2 and CH3NH3Cl acts as a buffer. Okay, so the first thing is CH3NH2. So to act as buffer, you have to show that basically this is base. CH3NH2 is a base, and CH3NH3Cl is basically the conjugate acid. Okay, so the base will deal with the acid added, the H plus added. The base is going to neutralize it to resist the change in pH. So CH3 and H3 positive. Okay, so now the conjugate acid CH3 and H3Cl. So this conjugate acid will go and neutralize the hydroxide ions added. So it forms CH3 and H2 plus H2O plus chloride. Okay, so these two equations show how the buffer deal with the acid and deal with the hydroxides. Okay, so now let's do a bit more. This side, phenylamine react with aqueous bromine to give compound F. Okay, so imagine that the bromines, the Br, will go to position 246 of the benzene ring. So describe the appearance of compound F. So it is a white precipitate. So white precipitate. Phenylamines react with nitrous acids to form a diazonium salt. State the condition for these reactions. Okay, so you must remember we need a low temperature. 5 degrees Celsius. The diazonium salt in part 2 react with an alkaline solutions of phenol to produce a colored compound G. So this is where they expect you to draw out the coupling reaction, the product of the coupling reactions. Okay, so the diazonium salt. Okay, let's do a quick revision. Diazonium salt is, okay, I put it in blue color first. Diazonium salt is a benzene ring with N. Then diazonium chloride, let's say, diazonium chloride. So there's a triple bond and Cl. So they react with phenol, right? It is the hydrogen that react with phenol. So what happened then is the HCl will be removed. Okay, then they will form a benzene ring, N plus, triple bond, and okay, no more triple bond already because they want to form another bond with the ring. So they will form these structures, OH plus HCl. Okay, so this is the azole dye. So our answer here, they expect you to draw the azole dye. They say the colored compound. So that is the azole dye. So which is these structures? Okay, so yeah, like that.